Hi students, in this video we are going to find the solution of a past paper, uh, physics past paper, paper 2 of AS&A Level, past paper of May-June 2022. Okay, let's start with number 1. Number 1, define velocity. Okay, velocity equal, or velocity is change in displacement over yeah, over time taken. Okay, again, velocity equal change in displacement over time taken. All right, I think clear. 1B, a rock mass 7.5 kg is projected vertically upwards from the surface of a planet. The rock leaves the surface of the planet with a speed 4 meters per second at time t equals 0. The variations with time t of the velocity v, the rock, is shown on figure 1.1. Okay, let's look figure 1.1. Okay, so on the graph. Okay, and let's look the question. Assume that the planet does not have an atmosphere and that the viscous force acting on the rock is always 0. So the viscous force always 0. Okay, in this case, right? Now, determine the height of the rock above the surface of the planet at time t equal 4 seconds. Okay, let me find the solutions of this case. We're gonna calculate height. It means we're gonna calculate the area under graph. Okay, and it means we're gonna calculate this area. Okay, triangle, the first triangle and the second triangle. Okay, now let's calculate. For the first area, the base is 2.5. That is one. Okay, this is 2.5. Okay, and height 4. Okay, the height 4. While for the second triangle, this is 1.5 base, and this height until here, I think negative 2.4 or 2.4. Yep. Okay, let's recalculate. This 2.4. This is 1.5. Okay. And this is 2.5. And this one 4. Okay, high. Okay, let's recalculate. Height equal. Okay, first triangle times 2.5 times 4 So the second triangle, a half times 1.5 times, let me see, 2.4. Okay. Okay. And it's going to be 2 times 2.55. Okay. Okay, 5. This one. Oh, sorry. Supposed to be this is minus, not plus, because uh, the second the second triangle here minus opposite with the first triangle. So it means 5 minus 1.2 multiply 1.1 with, okay, to the calculation becomes 1.8. So 5 minus 1.8 equal 3.2 meters. So the solution here 3.2. 3.2 meters. Okay, done. Next. 2. Determine the change in the momentum of the rock from time t equals 0 to time t 4 seconds. From 0 to 4 seconds. Okay. Change in momentum. Change in momentum. Change. Okay, change in momentum. I'm going to use this formula m times v2 minus m times v1, or through factorizations we can simplify this formula becomes m times v2 minus v1. Okay, and we may calculate mass equals 7.5. This information, this look, if you look this, okay, this equation, that mass 7.5 kg. Okay, mass 7.5 kg. Okay, 7.5 kg. Okay, 7.5 minus velocity 2, multiply velocity 2 minus velocity 1. You know that velocity 2 minus 2.4 as well. Okay, this is the velocity 2. Okay, this one, the velocity 2, while the velocity 1, this minus 2.4. Okay, 2.4, and this velocity 1, this 4 meters per second, and this one negative 2.4 meters per second, opposite with the first velocity. Okay. Okay. Now, 7.5 multiply V2 minus V1, V2 minus 2.4, V1 4. Okay. And it becomes negative 48. Okay. So the solution is a negative 48 Newton second. You may answer here minus 48. Okay. Right, next. Determine the weight W of the rock on this planet. Okay. The To calculate the weight, okay, weight, we're gonna use this formula, weight equal delta mv, okay, or change in momentum over delta t. Okay. As you know, change in momentum, this one, negative 48 over 4, and the solution negative 12 Newton, okay, or 12, okay. So the answer is negative 12. Okay. Next, in practice, the planet in B does have an atmosphere, okay, that causes a viscous force to act on the moving rock. State and explain the variations, if any, in the resultant force acting on the rock as it moves vertically upwards. Okay. So if velocity, right, I'm gonna type in here, if velocity decreases, if velocity decreases, so viscous force as well decreases. Okay, and if viscous force decreases and if weight constant, okay, so when velocity decreases, viscous force as well decreases. And if viscous force decreases and awake constant, okay, will be implication to uh, the resultant force. Okay, so the implication is resultant force decreases as well. Okay, okay. I think clear this. Okay, next. Number 2, state what is meant by the center of gravity of an object. All right, I'm going to answer here. Center of mass is the point at which the distribution of mass is equal in all direction and does not depend, okay, and does not depends on gravity field. Okay, this. So center of gravity or center of mass is the point at which the distribution of mass in equal in all directions and does not depends on gravity field. Okay. Let's look the next questions for this understanding. Okay. A non-uniform road XY is pivoted at point P. as shown in figure 2.1. Okay. Okay. In this figure, I'm going to okay, naming this yeah, this part. Okay, and 1.1 is this is D1. Okay, so D1 equal distance 1 equal 1.1 meters. Okay, while D2, okay, D2 equal 1.7 minus 1.1. Okay, D2, okay, equals 0.6. Okay, so this is D2, distance 2. And then for distance 3, uh, distance 3, this, okay, D3, okay, that one. So D3 equal 4 minus 1.1 at 2.9. Okay. Yeah. So distance 1, 2, and 3. This is F1. Okay, first one. This is F2. Okay, so F2 equal 44 newtons. And this is F3. F3 equal 3 newtons. Okay, F3 by sphere. All right. Next. The rod has length 4 meters and weight 44 newton. The center of gravity of the rod is 1.7 meters from the end X of the rod, okay, when P is 1.1 meter from NX. A sphere hangs by a wire from NY of the rod. This is the sphere. The weight of the sphere is 3 newtons, okay, F3. The weight of the wire is negligible. We no need to calculate the wire, negligible. A force is applied vertically downwards at an x, okay, so that the horizontal rod is an equilibrium. Okay, by taking moments about P, calculate F. We're going to calculate this one, F1. Okay, so F1, we're going to use this formula, F1 times D1 equal F2 times D2, okay, plus F3 times D3, okay? Or if we're gonna find F1, we may simplify this formula, becomes F2 D2 plus F3 D3 over D1. So F1 equal F2, that we look F2 D2, okay, D2, okay, yeah, D2 0.6, while F2 44. Okay, so 44 times 0.6. Okay, multiply. Okay, plus F3 D3. Okay, F3, this one F3 3 newtons, while D3 2.6. Okay, 3 multiply 2.9. Sorry, 3 multiply 2.9. Okay, over D1. Just now D1. Okay, D1 1.1. Okay, this is 1.1 and equal, let's we calculate 44 times 0.6. Okay, plus, okay, okay, this is 35. Okay, 35.1 over 1.1 equal 31.9. Okay, 31.9 newtons. Okay, so we may state here that force or F1 equal 31.9 newtons. Okay, so this F1 is 31.9. Yeah, wait, yeah. Okay, next. Calculate the force exerted on the rod by the pivot. Okay. It means we are going to calculate the total force exerted. Consists of F1, F2, and F3. It means force equal F1 plus F2 plus F3. Okay. So F equal 31.9 plus 44 plus, yeah, 3. And F3 equal 3. So if you calculate, you're going to have the result 78. Okay. 78.9 newtons. Okay. The answer here, 78.9 newtons. Okay, let's continue. See, the sphere in B is now immersed in a liquid in a container. Okay, as shown in figure 2.2. Okay, look at the sphere inside the container. Okay, and with the liquid density 1,100 kilograms per meter cube. Okay, this is the force of F2. I think this one. Okay, we're gonna calculate what here. Okay, then density liquid 1,100 kilogram per meter cube. The upthrust acting on the sphere due to the liquid is 2.5 newton. Yeah, 2.5 newton, the liquid. Okay. The magnitude of F is unchanged. Okay. So, so that the horizontal root is not in equilibrium. Okay. It's not in equilibrium. Okay. Use Archimedes' principle to determine the radius R of the sphere. Okay, we're gonna calculate the radius. It means we should using uh the formula of volume, but okay. But first we are going to find volume. Okay, volume afterwards. Okay, we apply volume equal pi r cube. Four third pi r cube. Okay. Mm. F this F 2.5. Okay, force. Okay, force 2.5. While rho this one. Okay, rho is 1,100. While gravitational force for the gravitational force, I'm gonna use 9.8. Okay, you may calculate. You may use 10. If you don't want to use 9.8, you may use gravitational force 10 Newton per kilograms. Okay, but I'm gonna use 9.8. Okay, let's recalculate. So to find force equal density or rho times g times phi. We're gonna find phi. Okay, it means we can arrange this formula. If phi is the subject, phi equal F over rho times gravitational force, or F 2.5, and over 1,100 times 9.8. Okay. Okay, let's calculate. This one becomes okay, 2.32 times 10. Okay, 10 power negative 4. This is phi. And let's we continue to calculate to find R. Okay, in the space, I'm gonna move. Okay, but let's we find the formula. Huh? As you know, that formula to calculate the volume of sphere, the formula is 4 third pi r cube. Okay, so it means r cube equal, yeah, 3 times phi over 4 pi. Okay, okay, I'm gonna move here. It means r cube equal 6, yeah, 6.96, okay, times 10 power negative 4, okay, over 4 times over 4 p, 4 pi, 4 pi Why 6.96? Because three times this one, three times this number. 3 times 2.32 equal 6.96. Okay. So R cube equal 6.96 times 10 to the power negative 4 over 4 pi. Let's we calculate through using calculator. Okay. It becomes 5.53 times 10 to the power negative 5. It means R equal, okay, yeah, power to the power 1/3. R equals 0.038. Okay, that's the result. So we state here that's R equals 0.038 meters. Okay, next continue. Calculate the magnitudes and directions of the resultant moment of the forces on the road about P. All right. And for this one, we're gonna calculate. Yeah. Okay. Calculate the magnitudes and uh, direction. So moment equal. Okay. This one. For moment equal this moment, not mass. Moment equal F times D. Okay. I'm gonna use this formula. So 2.5 Newton, okay, times 2.9, okay, equal, yeah, 2.5 and 2.9 because you look this graph, okay, recall this graph 2.5, okay, because when you look on this graph, okay, this one, okay, 2.5 and 2.9, okay, 2.5 is F, okay, sorry, yep, and 2.9 3, that one. Oh, sorry. Not on the graph, on this case, sorry, on this uniform. I mean 2.9, okay, 2.5 because force is 2.5. Okay, okay, 2.5 times 2.9 equal this one, calculate. Yeah, 7.25 Newton meters. Okay. Yeah. Uh, why 2.5 Newton? Because of this F, this one. Yeah, F equal 2.5 Newton, while 2.9 because of, yeah, 2.9 Newton, the distance, okay, I think, okay, this one, 4 minus 1.1, this, yeah. This is 2.9 D3. Okay. All right. Let's continue. So, okay. So the magnitude of resultant moment equals 7.25 and direction anti-clockwise. Okay. Okay, next. Define power. Okay. Power equal, okay, power equal work done over time taken. Equal work. Okay, work done over time taken. Okay. Okay, this is understanding of power. Power equal work done over time taken. Next. A force F takes time t to move an object through a displacement x at constant velocity v in the directions of the force. The work done by the force is W. Use the definition of power to show that the power P transferred by the force is given by P equal P equal F times P. Okay, let's discuss this. Um, so W, I'm going to write it W. As you know, W equal uh, F times X. Okay, F is force while X is displacement. Okay, F is force and X is displacement. It means, and then, sorry, and then P or power, okay, power equal W over T. Okay, so it means Fx over T. Or we may writing like this. We may arrange this formula becomes like this. F times X over T. And you know that X over T, displacement over time, is velocity. Yeah. So velocity equal displacement over times. Okay, so becomes F times V. Okay, uh, this one. So P equal F times V. Okay. A block is pulled up a slope by a wire attached to a motor, as shown in figure 3.1. Okay, look this figure. There are slope, block, wire, and motor here. Okay, and between this slope and a horizontal line, there is angle 11 degrees. All right, look at the question. The useful power output of the motor is 56 W. The block has a weight of 430 newtons and travels with constant velocity along the slope at an angle 11 degrees to the horizontal. Assume that there are no resistive forces opposing the motion of the block. Calculate the tension T in the wire. Okay, we are going to find the tension T. Okay, the tensions happening on this wire. This wire. Okay, right. The tension. Okay, okay. I will begin. Okay, I'm gonna use this formula. Tensions equal F. Yeah, this F. Okay, F times sine. This one, the sine 11. So 430 times sine 11. Okay, I just calculate recently, and the result. Okay, 42.82. I mean 82 point 0.4. 32.04. Okay, 32.04 Newton. Okay, that's the tension. Okay, so you may writing here 82.04. Okay, next, calculate the speed of the block. The speed, okay, speed equal distance over time taken. Okay, or speed equal uh also 56 meters. Look, is that the one? 56. Okay, the power 56 one. Okay, and then over just now time taken. So speed equal 56 over just now 82, if not mistaken. Wait, I'm gonna check. Yeah, 82.04. Okay, 82.04. Okay, let's recalculate. Okay, 0.69 meter per second. Answer is 0.69. Okay, next. The rate of increase of gravitational potential energy of the block is equal to the useful power output of the mother. One of the reasons for this is that there is no work done against resistive forces. By considering the motion of the block, state another reason for this. Ah, okay. Oh, yeah. Okay. I think there is no change. Okay. Yep. There's no change for kinetic energy. Wait. Yeah. Okay. Mm, there- sorry, there's no change for potential energy, not kinetic. Sorry. I mean for potential energy. Okay. Mm. Okay, next. The motor has an efficiency of 80%. Calculate the time taken for an input energy of 1.2 kilojoule to be supplied to the motor. Okay. Uh, let's see. Calculate the power input. Okay, power input. Yeah, power input. 56 over 0.8. Okay, equal 70 watts. Okay, and then the time taken. Uh, yeah, energy input is energy input over power input. Okay, energy input over power input. Okay, I'm gonna scroll down. Okay, this is energy input. Sorry. Okay, energy input. This one 1.2 kilojoule. 1.2 kilojoule or 1.2 times 8 kilo times 1000. Okay, okay, 1000 joule. Okay, over power input. This one 70 watts. It becomes divided. Becomes yeah this one 17.14 second. Okay. So the solutions is 17.14. Sorry, 14. Okay. Next. Number 4. A spring is suspended from a fixed point at one end and a vertical force is applied to the other end as shown in figure 4.1. Okay, this is the spring. Look, this is the length. This is a fixed point and okay, the force to downward. Okay, the variations of the applied force F with the length L of the spring is shown in figure 4.2, this graph. Okay. Determine the spring constant K of the spring. Okay, we're gonna find K. Okay. K equal force over delta L. Okay. Formula K equal force over delta L. Okay, or force 30 newtons. Force 30, yeah, 30 newtons. This point. Okay, and then delta L delta L is 0.6 minus 0.2. Okay, this one centimeters becomes meters. It means 0.6 and 0.2. So this is 30 newtons over 0.6 minus 0.2. So equal 30 newtons over 0.475. Yeah, 75 newton per meter. Okay. Next, determine the elastic potential energy in the spring when the applied force is 15. Okay, 15 newtons. It means we have to apply this formula energy. Okay, elastic potential energy equal a half times F times delta L. Okay, a half times 15, if it equals 15 Newton, this one. Okay, times 0.2. 0.2 because just now, okay, 0.2, 0.2 meters, elastic potential energy. You can see on the graph, the previous graph, and if you calculate, becomes 1.5 joule. Okay, so the answer here 1.5 joule. Okay, next. Number 5. A horizontal string is stretched between two fixed points A and B. A vibrator is used to oscillate the string and produce an observable stationary wave. At one instant, the moving string is straight, as shown in figure 5.1. Okay. The dots in the diagram represent the positions of the nodes on the string. Point P on the string is moving downwards. Okay. The wave on the string has a speed 35 meter per second and a period 0.04 second. Explain how the stationary wave is formed on the string. How the stationary wave, okay. I'm going to answer here. Okay. Two reflected waves. Okay. Two reflected waves of same amplitude and frequency at the ends of string are traveling in opposite wait, two reflected waves of same amplitude and frequency at the ends of string are traveling in opposite direction. Okay. And overlap. And overlap along the length. Okay. Two reflected waves of same amplitude and frequency at the ends of string are traveling in opposite directions and overlap along the length. Yeah. Okay. Next, continue to 5b. On figure 5.1, cats align to show a possible positions of the string a quarter of a cycle later than the position shown in the diagram. Okay, now we return back onto this graph, this figure. Okay, I'm gonna answer like this. I'm gonna look that point P directions to downward. Okay, means here there's a point here, and then this one, and then here, fourth point here. Okay, and then here. Okay, now we create a line. Okay, like this becomes the new graph. Okay, okay, like that. Okay, next, this one, number 5D. A particle on the string has zero displacement at time t equals 0, from time t equals 0 to time t equals 0.06 second. The particles moves through a total distance of 72 millimeters. Calculate the amplitude of oscillations of the particle. Okay, the particle needs 0.06. Okay, from 0 to 0.06, while total distance 72 millimeters. So amplitude equal 72 millimeters over 6. Yeah. So it becomes 12 millimeters. Okay. Yeah. Okay, let's continue. Number 6, state Kirchhoff's first law. Okay, Kirchhoff's first law state like this. The first Kirchhoff's laws. Okay, that right. This one. The sum of the currents entering a junction always equal the sum of the currents out of the junctions. This Kirchhoff's first law, the sum is the sum of the currents entering a junction always equal the sum of the currents out of the junction. Okay, let's continue. A battery is connected to two resistors, resistors X and resistor Y. Look on this diagram. As on in figure 6.1. The resistance of resistor X is greater than the resistance of resistor Y. It means we may write the resistor X greater than resistor Y. State and explain which resistor dissipates more power. Okay. If resistance X greater than resistance Y, it means power, okay, power of resistance X equal Px over Rx. Okay, you know that P equal P over R. Power equal a potential difference over resistance. And Py equal Py over Ry. Okay. If Rx, okay, if resistance X greater than resistance Y, will be implicated to the result of Px and Py. Okay, if this denominator Ry less than this denominator Rx, the implications is Py or power Y less than power X. Okay, or the conclusions resistor. So resistor, yeah, here. The resistor Y okay, dissipates more power than resistor X. Why? Because the number of this denominator. Yeah. If resistor Y less than resistor X, it means Py would be uh, greater than Px. Yeah. Oh, this one. Sorry, this one supposed to be Py will be greater because it has uh, Ry less than Rx. If this denominator less than this denominator, Ry less than Rx, implicated to the number of Py and Px. So Py will be greater than Px. So it means resistor Y dissipates more power than resistor X because the number of pi. Okay. Yeah. Because Vx, yeah, Vx equal Vy in this condition. If you look this, okay, if you calculate the from this point and this point, okay, they will be have same potential difference. Okay, so potential difference x same with potential difference y. If Vx equal Vy and Ry less than Rx, it means Py will be greater than Px. Like this, the mathematically symbol. Okay. Now, the next question. The two resistors are made of wires that have the same length. Okay. But wires are made from metal of the same resistivity. State and explain which resistor is made of wire with the longer cross-sectional area. Okay. Okay. And now, okay, this one. Resistor X and resistor Y, uh, based on the informations, have same potential difference. Okay, because X and Y, because X and Y as in parallel. Okay, as in parallel circuit. Okay, so like my previous explanation, that Rx, okay, greater than Ry. Okay, so Rx greater than Ry. And then it means uh, Rx, okay, equal rho times L over Rx. Okay, yeah. This formula. It means we may arrange becomes X. If AX the subject, it becomes AX equal root L over RX. Okay, and then it means RY. Yeah, RY equal root L over AY. It means AY equal rho L over Ry. Okay. Recall that, yeah, Rx greater than Ry. Uh, it means uh, A, AY, wait, it means if Rx greater than Ry, if Rx greater than Ry, will be implication to AY greater than AX. Okay, the result. Yeah. Okay. I think clear this one, this part. Next, C. A battery of electromotive force 9-volt and negligible internal resistance is connected in series, okay, with a like dependent resistor LDR. Okay, LDR and fixed resistor of resistance 1800 ohm as shown in figure 6.2. Okay, look, the potential difference 9 volts, and for this LDR resistance 1800 ohms. Okay, like this, right? So the question, a voltmeter is connected across the fixed resistor. The reading on the voltmeter is 5.4 volt. Okay, calculate the current in circuit. The current, it means we're gonna find I. Okay, symbol of current is I. Okay, I equal P over R. Yeah, it means I equal how much V? Yeah, 5.4. Okay, how much R? 1800. Sorry, 1800. Okay, so equal 1800 ohms. I mean, okay, this is 5.4. One volt. Okay, the potential difference. And if you calculate, you're gonna have the result 0.003. Okay, 0.003. 0.003 amps. Okay, or you may writing like this 3 times 10 power negative 3 amps. So the answer here 3 times 10 power negative 3. Or you may writing this number 0.003 amps. Okay. Next, calculate the resistance RL of LDR. Right. The potential difference, firstly, we are going to find, okay, the resistance. Okay, we're going to find the potential difference first of LDR. Okay, the potential difference of LDR, 9 volt minus 5.4. 9 minus 5.4. Sorry, 5.4 equal 3.6. Why 9? Because look at the total potential difference 9, while the LDR potential difference is 5.4. Plus. LDR potential difference. So the potential difference, yeah, the voltmeter, sorry, the voltmeter of this of yeah 5.4. Okay, the reading on the voltmeter 5.4. This one, if this is 5.4, it means this LDR, this one must be 9 minus 5.4. Yeah, because total potential difference is accumulations of this one of LDR and this electricity object. Okay, so 5.4 plus 3.6 equal 9. Next, we are going to find uh, resistance. So resistance or RL, this is PL, okay, equal VL over potential over electricity currents, and it becomes 3.6 over 0.003, okay, equal 1,200. So the solution here, 1,200 ohms. Okay. The unit of resistance is ohms. Next, the intensity of the light illuminating the LDR increases. Okay. Pay attention, this illuminating the LDR increases. Okay. By reference to the current in the circuit, state and explain the change, if any, to the voltmeter reading. Okay. Next, when sorry, here, okay, better here. Okay, when a LDR is kept in the dark place, the LDR light intensity will be decreases. Okay, will decreases, but the resistance is increases, is increases. Okay, so how about when the LDR in the light place? Okay, when LDR is kept in the light place, okay, its light intensity, the LDR light intensity, will increase. Okay, it increases, but the resistance is decrease. Okay. Okay. And of course, total current and total current will be increase. Okay. So the implication, okay, when LDR is kept in that place, its light intensity will decrease, but resistance is increases. When the LDR is kept in the light place, okay, the LDR light intensity will increase. Wait, will intensity. Okay, this one will increase, but resistance is decrease, and total current increases. So we're gonna say that voltmeter reading will be is in okay, is increases. Okay, yeah, okay. Next. Oh, number 7. An unstable nucleus, okay, X, A, and Z decays by emitting a beta negative particle. Okay. Determine quantitatively the changes, if any, in A and Z when X decays. Okay. Change in A, change in A equals 0 because better over here. Okay, change in A equals 0 because number of nucleon equal 0. Okay, while change in B, okay, equal -1 because yeah because number of proton, okay, proton equal -1. So the answer here 0, and this one -1. Okay, yeah. And next, in addition to the B negative particle, B minus particle, another lepton is emitted during the decay. State the name of the other lepton that is emitted. Okay. Yeah, another lepton is anti-neutrino. Yeah, anti-neutrino. Sorry, neutrino. And electron. Okay. Why? Because in beta plus, in beta plus decay, a proton is converted to a neutron, and a positron and a neutrino. Yeah, that are the conditions when beta plus decay. Different in beta minus decay. In beta minus decay, the weak interaction turns a neutron into a proton. When an electron and an anti-neutrino are emitted. Yeah, I'm going to explain later on another video. All right, now D. A particle P is composed of an up quark, symbol U, and a down anti-quark, symbol D. Calculate the charge Q of particle P in terms of E, where E is the elementary charge. So you're working. Okay. In physics, up quark or U has charge. Okay. Up quark or U has charge. U has charge plus 2/3 E. Okay. Okay. While D, okay, D or down anti-quark has charge plus 1/3 E. Okay, it means quark, uh, against quark, okay, quark is 2/3 E, okay, plus 1/3 E, okay, equal 1 E, okay, plus 1 E. So quark equal 1 E. Yeah, this one, sorry, 1 E. The unit is E. So quark equal plus 1 E. Now, particles P belongs to two classes, groups of particles. State the names of these two classes. Okay, of course, this is uh, hadrons. Okay. And the secondly is mesons. Okay, done. Okay, for this past paper, if you have any questions, you may ask me to this email, henrik.academy21@gmail.com. Thank you, students. Bye. See you.